Welcome to the YT University. Today we will study projectile motion. Visit our website ytuniversity.ph for more science topics. Projectile motion is a motion that happens in two dimensions. The object called as the projectile travels along the vertical axis and hence have a vertical component. The vertical component is affected by gravity. It is also an observable fact that the object, or the projectile's shadow, is moving parallel to the horizontal axis, and hence we proved that it has a horizontal component. Direction of a projectile motion. The projectile is projected at an angle theta. We can get the component velocities of the projectile using this angle and the trigonometric function. We use the sine function to find the vertical component, while the cosine function is used to find the horizontal component. The interaction between these components produce the path traveled by the projectile, which seems to be an arc of different lengths. We also note that each velocity component has its characteristics. As you may have guessed, the y component has a changing velocity and hence indicates the presence of acceleration. The x component has a constant velocity behavior. Here are the important notations that we should be familiar with when deriving the formula for projectile motion. These notations have meaning or concepts behind them. They are as follows. The initial velocity is also called muzzle velocity, is read as v sub o. The x component is read as v sub x, which is equal to v sub o cosine theta, is constant all throughout the course of motion. The y component read as v sub y is equal to v sub o sine theta, is changing in magnitude and direction. The angle theta is constant all throughout. At the same height, the velocity is equal but different in direction. We also note that the time it takes to reach the maximum height is equal to the time it takes for the ball to go down. As mentioned earlier, the y component is affected by the acceleration due to gravity. This requires us to use the free fall concepts that we have learned from our past discussions. We need to know the initial and final velocity component along the y-axis using the sine function. We also remind ourselves that the velocity of an object thrown in mid-air at its peak will be equal to 0 meters per second if solely acted upon by gravity. We plug the formula to the free fall equation and we can get the amount of time t that it takes for the projectile to reach its maximum height. We have time to get up is equal to v sub o sine theta over g. We may wish to know the maximum height of the projectile above the ground. We take note that the amount of time it takes for the ball to reach its maximum height is equal to the time it will take for the projectile to fall back to the ground. Hence we can use the free fall concept to get the height using the value of time to get up. H, or d, is equal to positive or negative 1/2 gt squared. The sign depends on the orientation from the origin or reference frame of the observer. But since we are talking about the height, it will be positive. We substitute the expression for t up, then simplify the formula and we get initial velocity along the y-axis raised to the power of 2 all over 2g. We can also use the other formula to derive for the maximum height. And arrived at the same answer. We now solve for the range of the projectile. The range is the distance traveled along the x-axis. We can use the fact that the time to get up is also the amount of time to get down. Hence the total time interval of the projectile motion is time to get up plus time to get down, or 2 times the time to get up. We also use the fact that the velocity along the x-axis is constant. We can use the formula range r, or d, is equal to v sub x times total time. Then we realize that this is equal to v sub o cosine theta times 2t up. This can now be simplified as r is equal to v sub o squared times sine 2 theta all over g. That's pretty much everything that you have to learn about projectile motion. If you like to learn more about science concepts, then click the subscribe button, hit the notification bell to get updated when we post new contents. See you next time here in the YT University.